At 0, we're going to have a height of 1 meter. This is in meters. That's where we're starting. That's what they told us to start with right here. After 1 second, what does he do? Can someone just tell us in words, what is he doing in this video? Yes, sir.
Walking up the stairs.
Goes up the stairs. Great. After we go up the stairs, he sits down. Does he go down the slide right away?
No.
Sits down and waits. Okay?
You skipped the part. That boy walked
Yep, he went up the stairs.
and then walked.
Oh, yes, there's a little platform. We missed that. Thank you. There's a little platform there. So he walked to the edge of the slide, and then he sits at the edge of the slide. Then he goes down the slide. We'll watch it one more time to see if we missed anything. Okay, we know he started. It took him a second. He's standing there. It took him a second to start walking up the slide. At about 5 seconds after he gets up the stairs, he's high off the ground. Then he walks straight across. So imagine this, right? He's walking up the stairs. Then he walks straight across. Does his height increase at all? No, so it stayed the same. And then he sits down and he waits, right? He seems to wait a pretty long time. And he waits. Then he finally goes down the slide. Why did it go from 0.5 to 1 meter?
Because he stood up.
Because he stood up, right? The level of the slide was way below his height. So now what I want you to do is, now that I broke it down by seconds, right? Time is seconds. I would label their X and Y values. Time is seconds. Your height is meters. Now what I want you and your team to do is to sketch the graph. We'll check back in a few minutes. Let's check our graph. How does your graph compare? How does your graph look? Questions? All right. Let's look at number 3 together. What is the least value for time in the graph? What is the most? Least meaning smallest. 0. So label this. The least would be 0. What's the most or greatest? 15 seconds. What we're defining here is called domain. Have you heard the word domain to describe X values?
No.
Yeah.
Domain and range. Have you heard those things? Okay, we're reviewing domain and range today. So in inequality notation, I could say my X values are between 0 and 15. I would write that down. That's the official inequality way to define our domain. We're going from 0 to 15 on our graph. That's it. For the height, what is the most? So what's the smallest height value?
0.5.
0.5. Good. Now we're looking at the Y values, or the heights. What is the highest or greatest or most? 3 meters. So then we can define our, this is called range. And we define it with Y. It's going to be between 0.5 and 3. This is, again, is official inequality notation. Questions about that? 0 and 15 and right here. What do you want to pick?
19. 4.
0 and 15. We'll do 4. So this is going to be 4. Number 6 says let t equal the random number you picked. So that means our time is 4. Can you estimate what is the height of that guy's waist, maybe using your graph, at 4 seconds?
That's going to be like 2.5.
2.5? You're estimating from your graph?
Maybe.
That's fine. Estimate using your graph. Again, we are picking a number that's not listed in the table. So again, we can use any values between 0 and 15 for a time value. 7. For this video and the time you chose, is there more than one possible height? That is correct. So let's think about this. At time 4, is it possible to have 2 different heights?
Yeah, he bouncing up and down.
You think he's bouncing up down? He's in 2 places at one time? No, he can't. Shh. We cannot be in 2 places good at the same time. Or can we? When we use a function, we've got a couple things here. So the first thing, we define domain and range. So we're going to use a couple different boxes here. So domain is your x values, and it's the set of all possible inputs. That's what domain is. Range is y, and it's the set of all possible outputs. For this next one, a little sketch of a graph. So this is the definition of a function. Functions for every input. For every input, there is exactly one output. And sometimes when we're using a graph, we check with the vertical line test. Have you heard of that one?
Yeah.
Okay, the vertical line test, I sketched an example up here, is basically saying at every point on this graph, is my graph 1 to 1? For every input, there's exactly one output. Is that true for this one? Yes. Sometimes people call it like the pencil test. You take your pencil and slide it through the graph and see. The last thing we're going to define here, we've been using function notation. I believe we saw some examples of this in lesson 3.0 or 3.0. Remember, what's inside the parentheses is your input. What it's equal is your output. So this is your x's, these are your y's. Input, output. We'll ask you to evaluate. So if f of x equals x plus 3, how would you find f of 4? What would you do? F of 4. You plug in 4 for x, and you simplify. You'll say f of 4 equals 7. That's the output I get when I input 4. In number 1, it says, does this table represent a function? No. Why? Because there are 2 x values that are 3. We'll circle it in the table. So it has two different outputs. So, and if you weren't quite sure of this picture, sometimes I recommend people graph it, right? So if I were to make a little sketch at 3, I would have a point at 5, and then I would have a point at 6, and that would fail the vertical line test. That would fail the vertical line test. It would hit the line twice. 2 and 3 in your teams. We'll check back in a minute, please. So I like to look at the graph like this. So for domain, it's x. So I'm going to look left to right. So my smallest value on the left is -4. My largest value on the right is 5. For my range, it's my y. And I like to look up and down. So my smallest y value is... What's the lowest y value? 0.
Oh, yeah.
What's the highest? It's fine. What's the highest y value? 5. It kind of goes off the graph over here, but it looks like 5. It kind of goes off the graph a little bit. The next one would be 5.
Look at 6.
It's not 6.
How you know that?
Because
How about part D? What is the x value when your y is 3? So go to y is 3.
-2.
-2 or 4. Is that okay? Can we have 2 of them?
Yep.
Yes. It's -2. And our answer is also 4. This still passes the vertical line test. That's okay. If you look at the screen, I drew a horizontal line at y equals 3, and I found my 2 y values. How do we feel about functions?